Jiri framework. Hot chocolate, red well. Azure Cosmos DB. Data. Entity framework, our tools. Networky suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shay Rojansky.
Grace Lanson.
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Awesome. We are live and in a pretty interesting state, I would say. So hello, everybody. It's me, Jiri Cincura, and Shay together with me. As you can see, it's Thursday, which I learned yesterday that we've never done the community stand-up on Thursday. And it's also basically 1 week after it was originally scheduled. To give you a little bit of the explanation what happened. I was sick. And at that time, half of the team, or maybe 3/4 of the team, were on vacation. So there was nobody else to do it. So we decided to shift it 1 week. But yesterday, we had another meeting colliding with this time. So we needed to shift it for Thursday. So it's 2 new things in one stream. It's a Thursday and it was shifted, which apparently never happened before as well. So yeah, here we are. Hopefully here we are. So Shay, do you have something to say about this one?
Not really. Many exciting changes. I don't know if I'll survive all this dramatic change, you know.
We will see. Maybe we'll do the stream on like random days to keep people like alert, you know.
Yeah.
It will be Monday and Tuesday and Friday and whatnot.
3 a.m., 5 a.m., maybe. Yeah.
Yeah, that would be awesome. And we can say that it's basically to cover all the different time zones. So yeah.
Sure.
But yeah, the 2 a.m. that's you probably only, not me.
Yep.
Anyway, maybe you can see, well, not see, maybe you can hear that my voice is not 100%. Maybe I will be coughing a little bit and everything. So I apologize in advance. And the topic for today's stream is Chroma DB. Maybe you noticed a couple days ago, we published a blog post announcing the low-level SDK for ChromaDB for .NET. So if you want to use ChromaDB, and we will get into what ChromaDB is in a second, you can now use it from C#, from .NET, because it's available. It's available on NuGet. You will see that in a moment, and you can start playing with it. So, Shay, do you know what ChromaDB is?
I think I do. Do you want me to ask questions, or
yeah, I don't know.
to
Maybe you
answer
can
them?
tell us what Chroma is.
Well, it's all about vector databases, right? Maybe we should do like a quick introduction to what vector databases are.
Sure. What is a
Does
vector
that make
database?
sense? You want me to talk to this? Yeah. So yeah, vector databases are. It's not a new thing, but it has become everybody has now talks about vector search and vector databases, especially because of AI. So it's one of the critical components in most AI stacks. When you're doing an AI application nowadays, there's a pretty good chance you're going to be doing vector searching. Vector databases are a dedicated kind of database. It's usually a database that's built specifically for the task of finding similar vectors. So vectors are just strings of numbers, basically. And vector databases are very good at storing tons of those things. And if you give it like a new vector, it is very good at finding the 5 most similar vectors to the vector that you gave. So basically, this is basically the point. Why is that important? Who cares about like strings of numbers and vectors and all that stuff? Basically, it turns out that when you take, for example, a text like words or whatever, or an image, anything you want, then what we can do is we can convert the text into a string of numbers, like into a vector that conveys the meaning of that text. That's basically the magical part of this whole thing. A vector that represents the meaning of something in this way, usually, sometimes you will hear the word embedding. We talk about embeddings. Embeddings are basically just vector representations of something like text or an image or whatever. And you will do this because what you're usually looking for is for text that's similar to text that you already have in your database. So I'll jump ahead to a very, very common case, like the usual case where you use a vector database. For example, let's say you have a store, an online store, and there's products there. You have whatever, boots and shoes and stuff like this, and you want to have a search. So a traditional search, the user will put shoes in there. Then a traditional search will simply do a string search, right? Maybe even a full text search. So it will find products that have the word shoe in the title. Maybe if it's smart, and the user who wrote shoes, it's smart enough to know that shoes is the plural of shoe. So it will also look for products that have shoe in them. So that's nice. That's full text search. But for example, it will not show boots. Whereas it stands to reason, if a customer is looking for shoes, maybe they're also at least interested in boots. And maybe there's another synonym, like another thing, like stuff you wear, right, on your feet. Maybe something with feet is also a good candidate for a product. So those kinds of things are semantic similarity. It's no longer just the stupid search of strings, right? And that's exactly what vector databases do well. You can take your product description, turn it into a vector, and then you can do a similarity search in the vector database very efficiently. So that's one very common use case for vector databases. And I promise I'm going to shut up right after this because I'm talking a lot. And after the second thing, which really is more of an AI thing. So what I just described is we usually call semantic search. You can call this AI if you want because it's dealing with meaning already and so on, but it doesn't involve an LLM. This is not Gen AI. It's just using a vector database to do semantic search. But what you can do, which involves an AI LLM, is a pattern called a RAG, or a retrieval augmented generation. Here, the problem is basically that an LLM, all of the LLMs, they have been trained on a lot of data, and that's cool. But all they know is the data they've been trained on. They don't know, for example, the data that you have in your company. If you have your product catalog, which you just developed or whatever, or you have your legal company and you've got a lot of legal precedents or any text or whatever that you have, the LLM doesn't know about it. So if you or your users or whatever, you ask the LLM questions about stuff that it doesn't know, you will at best get no answer, and at worst you will get hallucinations. So the problem is, how do we augment the LLM with your data? How do we add memory? How do we add knowledge to an LLM? So you can do fine tuning. That's one thing that basically kind of, let's say, retrain or additional training for the LLM. That's usually quite expensive and complicated. What you usually do is you use this pattern called RAG. all you do is you basically take all your legal things or your products or whatever, you vectorize them, so you generate vectors, embeddings, and you shove them in your vector database. And your vector database now represents like the memory, auxiliary memory, additional memory of your AI. Now, when the user comes along and asks for boots or shoes or whatever, before you send that query into the LLM, you first vectorize it and send it to your vector database, and you ask, give me the 5 most similar texts to what the user just wrote, and you will get back the stuff from your company's knowledge base, like the product catalog or whatever. You'll get back texts for 5 different products, and this stuff you basically shove into your prompt. You put it inside your prompt as context for the prompt for the LLM, right? So what you're sending to the LLM is no longer just the query from the user. You're also sending it some context from your company's knowledge, basically, and the LLM will use that to generate a real response. So that's basically my very long speech on what vector databases are. They're a critical component wherever you need to do similarity search. That's the key word. Similarity is useful in many scenarios. Semantic search, augmenting an LLM with whatever data you want to augment it with, and there's various other places where you can use vector databases. I think I'm handing it back to you now.
Awesome. I will be playing dumb, which is for me pretty easy.
I thought I should play dumb. I thought dumb was my thing. Okay.
We can both be dumb. That's fine.
I can do it so well.
Is there some special indexing for vector databases, or is it just like, like indexing numbers, the same as I'm indexing primary keys?
Good question. That's a very good question. It's not a dumb question at all, in fact. So yeah, obviously. So sometimes, like the trivial thing, like sometimes you will do what's called a flat lookup. Flat lookup just means you get a vector, you go through all the vectors in the database, and you compare them, and you find the most the topmost 5 similar ones. This is quite inefficient. If you have a ton of vectors in your database and you're scanning all of them every single time, that's not going to go well. A bit like in traditional databases, our crowd is probably more in the traditional database kind of thing. Then, in traditional databases, you want to avoid a full table scan. That's basically what I just described, right? A flat index. Yeah. So the point of vector databases usually is to have some sort of efficient indexing. Indexing vectors is a super hard problem. It really is. Anybody who's interested, like unlike traditional vector data, traditional relational databases, indexes in databases are not that hard actually to understand. Like algorithmically, it's basically like an index, right? You can think about it as a sort of a hash table or whatever, like a phone book. It's not that hard to understand in a traditional databases. However, a similarity index for vectors is very, very complicated, and the algorithms are pretty serious. I actually don't know how it works. I have a thing on my to-do list to actually research this and understand it better, but I can't actually tell you how it works. For example, one of the most popular indexes is called HNSW, hierarchical navigable small worlds. It's called. I have an idea. It's a hierarchical graph-based algorithm. I have some idea of how it works, but I don't know it to the detail. You don't need to know, of course. That's for the really smart people who design vector databases and their indexes. All you need to know is that, of course, you set up the index, you tweak it, you configure it a little bit, and then the vector databases does its thing super quick. And that's what it's there for. By the way, I will note one thing that I left out from my previous thing. Originally, you had these dedicated vector databases like Chroma. There are other names. Now, because vector search is so important for AI and everything that's happening, basically all the regular relational databases are integrating some form of vector search as well. So you can basically take an Azure SQL database or a Postgres database or a SQLite database, and you can put your vector data inside and do some forms of similarity search and vector search inside your database so that you don't have to install an additional product. There are pros and cons to each approach. So you might want to go with a dedicated product. That's all they do. So they do it sometimes better than the solutions that you get inside Postgres. They have more indexing strategies, more features, and so on and so forth. But sometimes it's really worth it to just have the data in the same database, and then you can have one transaction to update and to manage both of your, both types of data, and you don't have to worry about synchronizing data back and forth from them. So that's like an interesting conversation. Do you want to go with a dedicated database, or do you want to integrate it into your normal database relational? That's another question.
Yeah, another benefit with to have the data with the relational database is that obviously you can do filtering on both the vectors, the embeddings, as well as some other properties like, I don't know, like
But I thought
customer
you were
ID or
supposed to
what.
be the dumb guy.
Oh,
What's up?
okay.
No, I'm kidding. Yeah,
Okay.
you're right. You're right. Like that's a super good example. Like filtering all of it. Like usually the dedicated vector databases, they of course also have filters. Usually you do need the capacity to apply some filter before you do the similarity. So before you start looking for the similar vectors, you pre-filter usually with a traditional kind of keyword-based filter. But the capabilities of databases like this are very, very limited compared to relational databases where the filtering capabilities are just infinite, right? Like Postgres,
Yeah.
SQL Server, you can do anything with SQL, whereas databases like Chroma or Quadrant or Milvus or Weaviate or Pinecone, all of these dedicated vector databases, their support there is not going to be as impressive. So very good point.
Okay, I will bring in Visual Studio and let's jump into the code. So as we mentioned, the Chroma is a vector database where the main goal is to obviously have the efficient lookup for some embeddings. At the moment, you can have basically two modes of deployment. The first one is running it in a Docker container, which is what I'm doing. So it's running locally and not relying on the internet, which is a little bit easier. Obviously, during the live stream, it wouldn't matter because if my internet goes down, then the live stream goes down. Or you can sign up for a preview on trychroma.com, and that's basically cloud-hosted version. That means you are not running anything locally. You don't have to install it, configure it, yada, yada, yada. It's running in the cloud, and you have the benefit of the cloud, basically. So let's remove the code, and let's start with adding some NuGet packages. So as I mentioned, the Chroma SDK is now available. It's the version 1.0, which obviously will have some rough edges, and I'm pretty sure that people will find some issues with it. But the plan is obviously to go into, let's say, version 2 or whatever the next version will be and improve it. It's all open source, available on GitHub. So if you go and look for the NuGet package, you will obviously get the link for the GitHub, and you can look at the implementation, you can contribute, and so on and so on. So let me install this package, and we can start playing with it. ChromaDB by default is using communication over HTTP. So that's what we will be using. So let me do the simple stuff like ChromaDB client, obviously. Then we will need some options. Copilot is trying, but not really there. We have a Chroma configuration options, and I need to specify basically where it's sitting. So in my case, it will be localhost. The port is 8000, and the API version 1 is being used by this SDK. Chroma is actually deprecating the version 1 and introducing the version 2. We will probably improve this one. If you look at the GitHub repository, typing this one is kind of like, what is it? How can I get it? So yeah, we have an issue for just specifying the host name and optional report, and the rest will be done for you. Then I will need an HTTP client. So just create a new HTTP client, obviously in a, like, I don't know, ASP.NET Core application, or let's call it the real world application. You would have this one injected. And finally, Copilot is trying. I need a Chroma client. This one is...
Jiri, your screen is not showing up on YouTube. People can't see your code. That's weird. Ooh. Because I can see it in our backend thing.
Yeah.
I'm not sure. You want to maybe try to unshare and reshare?
Let's try that. because without the screen,
It's
kind
a
of
bit
sucks.
silly, right?
Yeah.
Without the screen.
Let me bring it in. What about now?
So 1 second, I'm looking at the YouTube. I'll tell you in a second. Yeah, now it looks good. Now it looks good, I think.
Awesome.
Cool. Problem solved.
Problem. Well, did you try to turning it off and on again? That's
Exactly.
what we did. I wouldn't say we solved the issue, but it's fine. So what's this one? Copilot was almost right. It's just the order of arguments is the opposite. So good. We have the Chroma client, which will help us access the database, query the database, and everything. Just so I can test that everything is actually working, let me do get version just to make sure that everything is fine. Oh, I need to do another dance because obviously I was sharing the window.
So
and
now
I need to share the screen so we can actually see the output.
I'll watch you on YouTube to make sure.
Just let me know when it's back there. Hopefully it's back there.
YouTube lags a tiny bit.
Yeah.
Sorry for all these delays, people.
It's fine.
Nope. So I think it's the full screen sharing. That's maybe the problem.
That's weird.
So I guess you can do the window sharing.
Full screen sharing before. Let's try again. Because why not? The problem is that there's not much we can do, right? Because we see the stream in the StreamYard with the screen and everything.
I mean, if this doesn't work, we can just try to shift back to just window sharing. Yeah, it still is not working, unfortunately.
Not working?
Nope. Try going back to the window sharing.
That.
And then we'll just have to believe you.
Window. Let's do this.
That's weird. I've done this for very long and I've never seen this.
Yeah. Maybe it's something in between. I don't know.
Yeah. I'm waiting for you to on the YouTube.
Yeah.
Come on. Come on, YouTube. You can do it. Oh dear. It doesn't seem to be showing.
Really?
I don't know what to tell you, man.
Let me try what I did before. I had the window not maximized. Maybe that's it.
Try.
Putting it into stage. Well, we can always do like jokes. Or...
Let's give it another try. Or I can try to share and then you tell me what to write or something like this.
Yeah, we can do
wow,
it.
It's really not working.
It's really not working.
It's really not working on YouTube.
Let me check on my side, the YouTube. Maybe it's you. Hopefully it's you.
No, people in the chat are
people
also
in the
saying.
chat. Yeah, okay.
Yeah, I don't think it's YouTube.
Yeah.
It was working there for
a brief moment. It was working.
Yeah. I don't know what to tell you. Did you do anything different?
Not really, no. What if I do?
this
Let me try
this
this
is embarrassing.
and this, just in case.
I'm waiting for the YouTube. But I'm guessing it's a problem there with
a StreamYard, yeah.
Oh, it's showing. Don't do anything. Don't breathe. Don't move.
Okay.
Just
so everything
stay.
needs to
Just stay
happen
like you are.
Okay, yeah.
All right, good. We can at least move on.
Yeah. So I will do it from within VS.
Nice.
I can zoom this one.
That's very creative.
Yeah. Anyway, so let me do .NET Run just to make sure that it's working. Well, it was working before, but you never know. Oh, there it is. We have some version. So yeah, we have some kind of output. I don't know why I can zoom this one, but yeah, at least something. Good. So in Chroma, you are storing stuff into so-called collections. You can think about it as a table or something like that. It's called a collection. So let me get or create a collection. So basically, I specify a name for a collection. Let's call it Shay, for example. And you can also specify a bunch of extra stuff, especially the metadata could be something useful in case you need to have some extra stuff around this one. I'm in this one using the get or create, which means if it already exists, I will get the collection. If it doesn't, it will be created for me. So as we are rerunning the application, hopefully it's going to be fine. And to access the collection, we need to create a client. So in this case, it's called collection. That's not really I need Chroma collection client. I will pass the collection and the HTTP client. I even think we have an extension method that will create this one for you, but I'm just creating it manually. Let's go collection client so it's not colliding with the other client. Oh yeah, I need options as well. Good. Still missing a piece of code. Now VS is happy, or compiler is happy. Good. So to store something into the database, obviously we need to store something, right, Shay? We need to create this vector. Do you know how to create this vector or something?
Yeah, good question. I mean, a vector is just a string of numbers, right? You should be able to create a .NET array with some numbers.
Yeah, but is it a real vector then?
Who cares? It's just a vector database.
What if I use Olama?
Oh wow, you're going deep. Very nice. This is more. This demo is more in depth.
Well, we need to generate some real.
No, it's awesome. So basically, what I was assuming, I was suggesting we can just make up numbers and create a vector. But what Jiri is going to show is actual AI magic to generate vectors from a real text, right?
Exactly.
That's amazing.
That's what I'm going for. So what I'm using is Microsoft Extensions AI, which is a package that obviously you can use as well. In this case, I'm using Microsoft Extensions AI Olama. Olama is like a local application that allows you to run these LLMs and other pieces. Obviously, you can use the Azure OpenAI stuff and other places. But I'm running it locally. It will be a little bit easier than going to the cloud and playing with connection strings and everything. And what I need is obviously the embeddings generator. So I think it's called Olama. There it is, embedding generator. I need to specify where it is. Do you know the port, Shay, from top of your head?
No, unfortunately not. For Olama, I don't remember the port.
11434. I hope it's that one. And some model. So I will use all mini LM. because I think I have this one local on my machine already downloaded. Good. And this generator allows us to generate embedding vector. So basically, I will give it a string as a value, whatever that is, and it will give me the read-only memory of floats, which is the representation of my text or whatever it is, right? I have an idea. What if we store our names into the database and then ask for a query that will be querying for like a dog, something that's completely related to our names.
Don't you want something with actual meaning that we can actually play?
Wait a minute. Stay with me.
Are you saying my name sounds like a dog?
Exactly. Who is closer to the dog, you or me?
It's your demo, man.
Let's try that. This is completely unscripted, so it can probably go really, really bad.
The best kind of demo.
Exactly. So it will be you and me, and let's try something that's actually an animal, but it's not a dog, like chimpanzee or something like that, right? Did I spell it correctly?
I think there's another E, no? But doesn't matter.
At the end?
Not sure.
Okay, well.
Maybe somebody in the audience will correct us.
Exactly. Okay, generator embedding vector for the item. So basically this one will call into the OLAMA using this model and give us back vector. In this case, mini-LM is like 384 or something like that items, right? And we will then store it into the database. So in this case, a collection client, add, and we can specify multiple items. I could probably generate all the embeddings at once and everything, but yeah, I'm already in the loop. So let's do it the like slow way, probably. We need an ID that can be in Chroma, whatever you want, GUID, integer, string. So in my case, it will be string. In this case, the embedding is actually the vector. And that's probably all I need, right? In case of Chroma, there are other options that you can store together with your data. And it's basically two things. First one is something that's called metadata. Again, it allows you to store extra information around your item. It might be, if you are storing like a product catalog, it might be maybe price or something like that, maybe number of items you have in stock or whatnot.
And that's an important point, because otherwise, if you're just storing vectors, that's all pretty useless, right? Like you can ask the database, give me the 5 most similar entries, but then what you get back, the vectors themselves don't mean anything. They're just a way to perform the similarity search. So usually you will be having the metadata which you fetch back. So in fact, in most of the vector databases, you do the search, you send in a vector, it does its thing, and what it gives you back, it doesn't give you back the vectors. It only uses the vectors to search on the index and so on. And what you get back is the metadata part. That's usually what you want to do with vector data. So nobody cares about the vectors.
Exactly. So let me store something in it as well. So what I will be storing is a key value pairs. In this case, it's a name. And because our item is actually a name, well, not the chimpanzee, but whatever, I will store the name as well, so we can do some extra filtering and whatnot. What you can also store with a Chroma is the documents. So basically string, and it can be whatever you want to store together with your item itself. We don't have any documents or anything. So yeah, probably the metadata is fine for us. Good. That should be it. Let's try running it and see what happens. What do you mean? extensions does not exist in with Microsoft. What happened? Oh, I
You're
forgot
missing
to.
some CSS.
I forgot to save
some package.
the CS proj file. Yeah. Let's try again. Awesome. It's doing something. It probably started. No exception. That's always good.
Should we recap what we just did, because it's less obvious maybe for some people than it seems, right?
I was exactly going for that one. Yeah.
Awesome.
So yeah, what we did, I installed the Microsoft Extensions AI Ollama package. So the Ollama as a platform that allows me to work with these language models. And I'm using this Ollama embedding generator to connect to it. I'm using this all mini LM model that will be generating the embeddings. And on this embedding generator, we have one handy method, which is called generate embedding vector async. I give it a string, which can be whatever you want. It can be a sentence. It can be one name. It can be, I don't know, whatever, just a string of something. It might be text extracted from PDF. It generates the vector for me. I get it in here. And then I store it in the Chroma database using this collection client. These weird characters around are there because you can store obviously multiple items in one go. I'm already in the for each loop. I kind of, well, it's unscripted. So normally you would probably generate the embeddings for multiple items to save round trips and everything, and then store it completely. In our case, I'm doing it one by one. It's probably fine.
Maybe it's worth saying one word on the model there. So you see there's the model ID, which in this case is all mini LM. So it's a model that comes with Ollama with the installation. Different embedding models exist. So you can select different models to generate your embeddings, and you know they're going to be different depending on various things. The most obvious case, of course, is if you want to, for example, now do images instead of text, you can do this. And think about that. That means that you can now do you can do similarity search over images, which is a bit wild, right? It's like it's that easy. You can just change the model ID into something that will accept basically image data instead of, you can use the DeepSeek embedding model as well. So that's a thing that you select. It's one of the only things you have to decide on actually is which embedding model you're going to use.
Exactly.
And that's going to, that's basically what I wanted to add here.
Yeah, we can
be careful because now your program is going to insert like these things over and over again every time you run it. So you're going to have multiple copies of Chimpanzee and Jiri and Shay.
Right.
Careful.
We will see. That's fine. That's fine. So to get into the meat of stuff, well, let's do actual search for something. So first we need the dog vector because we want to know who is closest to the dog, whether it's me, Shay, or chimpanzee. Awesome. Thanks, Copilot. So I will generate the vector for the word dog. And on the collection client, there is a handy method called query that allows me to pass, again, bunch of embeddings, number of results, and some extra filtering that I can do. So let me do dog vector. Number of results, by default, Chroma returns you a 10, but let's say I'm only interested in 5. And some extra stuff to filter on. We will get back to that in a second. But what I will also do, because I need it, is include the distances for my query. Ooh. So basically what I'm saying is, give me something that's closest to the dog based on the vector, give me 5 results. But in the result I'm getting back from the database, give me also the distances so I can actually see like how far it is or who is the closest and so on. So let's store it somewhere. And we can probably just for each through it. And yeah, that looks okay. Copilot was spot on. Yep, looks good to me. So I will get the result back. In my case, it should be up to 5. I will print the ID, which in our case will be the name of you or me or chimpanzee, and the distance. So now the moment of truth, right? This is so
Indeed.
stupid, right? Who is closer to the dog, me or Shay?
That's
Let's
pretty
do
funny.
dotnet run. Well,
Nobody. What
nobody.
happened here?
Well, I forgot to save my program because obviously
Ah,
I'm running from the console, and the console does not really matter. Ooh, so chimpanzee is
nice.
closest to the dog. I take it, but you are closer to the dog than I am. By a
What
little
a-
bit.
Right. So you see the distance, the numbers there
Yeah.
are like the distance between Shay and dog, and
Yeah.
then between Yiji and dog. Like you get this
Exactly.
idea that we're talking about distances here, right? Like that's the
Yep.
similarity. Similarity is basically
Exactly.
about distance, right? And vectors, like if you know vectors from math, like usually we think about vectors in two-dimensional space. This is like the distance between these two vectors, like how similar they are in the vector space. Super fascinating. It's very magical too.
And the idea behind the embedding generator is that for like stuff that is similar in terms of like real world similar, like shoes and boots, the vectors will be closer together in the space compared to like shoes and dogs, because shoes and dogs are not that similar.
Super cool. I'll go and think about what it means that I'm closer to a dog than you. Now I have a lot to think about.
Yeah, maybe
Maybe.
we can try some other names, right?
Sure.
So anyway, this was kind of like, hey, give me whatever is the closest, but we still have this extra set of information that we can use for some kind of filtering and whatnot. So that's something I would like to do now. So we actually cover a little bit of what's available in here. So if you look at the hint that Visual Studio is giving me, there are 2 extra operators that I can specify. One is filtering on the documents. Obviously, we don't have any documents, so that's not interesting for us. But we can also do the filtering on the metadata. So that's what I'm going to do. And well, Copilot was close, but not really. What I've done here is, because the Chroma has a simple filtering language, it's probably not worth having like full link support the same way we do in, for example, Entity Framework. So there's a
I have
really
something
limited...
to say about that later.
Oh, okay, yeah, but you are closer to the dog than I am, so that's fine.
Indeed.
So anyway, for the version 1, for the version 2, Shay will implement the full link support and everything. So for the version 1, we have a small set of operators that you can basically call. It's a bunch of static methods and a small language support in terms of like C# operators to do the basic filtering and or not and so on. So on this Chroma where operator, it's a bunch of these: in, not in, greater than, greater or equal, and so on that you can use. And you can use and or, and that's about it, and or not, to get into your condition. So if I do like not in, it gives me what I need, like the column, we would say, or the property. In this case, it's the name. And if it's not in, I don't know, test. So that basically means if I would have an item in here that has a name called test, then this test will be matched against that value, or in this case, not matched against that value. So now if you run it, unless I messed up with the not in and in, oh, let me save it. We should again see the output, because not in test that like matches, because chimpanzee is not a test and Shay is not a test. Well, maybe Shay is a test, we don't know. And
It doesn't
I'm
think
not,
so.
well, I'm maybe a test, we don't know. And definitely the audience will never know. I mean, I'm never going to tell them, right? So yeah, that's about it. And because we already have the DeepSeek in here, what about a different embedding generator? Let me restart my Docker container so we have like a fresh stuff. And in this case, it was chimpanzee, Shay, and me in this order closest to the dog. Let me try running it again with a different model, and obviously going to take a little bit longer. And maybe we will get a different result.
Why is it taking so long?
I don't know. There it is.
Very interesting.
So,
completely different.
Completely different. In fact, it's really completely different, because DeepSeek thinks that closest to the dog is me.
Yep.
Then it's Shay, and then it's chimpanzee.
Yeah, I think like to really appreciate this, you would put like sentences inside, like stuff with more meaning, or right, and like basically give more information here to the whole thing, and then you would start seeing results that are a bit more predictable and which make sense a bit more across
we can
models.
do that.
Sure, yeah, let's do it.
Shay lives in Germany.
Let's try it.
There it is. And chimpanzee lives in where does chimpanzee live?
Sure, or in the zoo.
Zoo. Okay. Zoo, not Zoom.
Exactly.
All right.
And then what's going to be our query?
And what's our query? Who lives in zoo? That's too easy, right?
Too easy, yeah. Who lives close to Prague? Maybe something like that, or
chimpanzee, because there's a zoo.
Could be. Technically, that could be correct, as long as it's not me.
Correct, yeah. Let me restart the.
It's super fun. Like, folks, the thing I like most is to play around with AI like this. Like, you can see it's so funny and interesting to see what kind of answers you get. And by the way, once again, here, there's no generative AI actually happening, right? Like, it's important. There's no LLM here. We're just doing similarity search. Oh, so interestingly, the zoo is supposed to be quite similar here. But at least I'm last because I'm in Germany. That's good.
Yeah, but like Germany and Prague, not really that far. Well, for you, definitely, you live in Berlin, but the AI does not know it. The only thing that AI knows is that you live in Germany.
Still, Prague and Czechia are supposed to be more closely associated, right, than Germany and
probably. But I'm also running the DeepSeek. I think it's the default one, which is like 7 billion parameters or something like that. So it's a small model. I downloaded it before this stream, and it was like, I don't know, 4.5 gigabytes or something. Probably if you would use the bigger versions, like, I don't know, 40 gigs or something, we would maybe get a different results.
And I'll note that I think in many cases, people, you're not necessarily going to be installing Ollama and running embedding generation locally. You're likely going to be accessing some cloud service to do it for you. For example, you can be using OpenAI on Azure or something like that, and then you go to all you do is you use the the OpenAI SDK. You do a call. It's pretty simple. It's pretty fast. You pay by the number of tokens. Like, it's not a big deal for the embedding generation. It's all very, very simple. Here, Jiri actually set it up locally, which is like another interesting step in a way. You can do it, right? But yeah, you will likely be doing this in the cloud.
There is one thing that's important to note, is that I'm running it locally, but even when we started with the DeepSeek, which is a little bit bigger model than the previous one, it took, I don't know, a couple of seconds for everything to kind of like warm up and start providing results. If you are having like a real world application, either you need a decent amount of like computing power to process all your requests for embedding, or more realistically, you will be using like Azure OpenAI or something like that, where you send the data, get the vectors back, and you don't have to worry about like scaling your machines and having enough GPUs and everything, because it's not something that would be computationally easy, even if you have like a decent machine with a decent GPU. It's a different beast running this in production. Awesome. Any questions, Shay?
From me?
Yeah.
I do have a question. No, but it's super stupid. It's like so uninteresting compared to everything we're talking about. I'm kind of asking myself, is it possible to, if you scroll up to the top, I can see that you have to create a Chroma configuration options, and then you have to create an HTTP client, and only then you can create a Chroma client. So can we do like a nice syntactic sugar and just instantiate a Chroma client with a URL directly, and then get everything like just working by default without 3 lines?
Not at the moment. What I can
just
do
an idea
is obviously like cheat, right?
Sure.
I can do this.
And then put the
but then I
HTTP
need
client
the same
inside.
options in here. That's why I put it into variable and everything.
I see. Okay, sure. Yeah, so maybe some future improvements for usability here.
Exactly.
Like that.
Yeah, we definitely have some issues for this one. The plan would obviously be to have it as easy as possible to start with, without affecting the like configurability and everything. So for example, there's another piece in the configuration options, which is the Chroma token, which if you are running with the cloud hosted version, you need to specify the token that was provided to you. Some kind of authentication. Obviously, I am running it locally, so it does not matter. In fact, locally, I can put whatever I want in there.
It makes sense.
Basically,
makes sense.
Awesome. So let's explore the API a little bit on what we can do. So we can create collection, delete collection, get collection, and so on. So that should be pretty easy. Same stuff like create, read, update, delete. Let's check. Maybe scroll a little bit down. On the collection client, what we also have. So we have add method that allows you to insert stuff. We have also upsert, which will do insert or update. Pretty simple stuff. There's also the update and delete. But what we also have is obviously a count to give us the number of items we have in the collection. But there's also a get method. So sometimes you are not really looking for doing the similarity search based on the embeddings, but you already have the ID and you need to fetch the data from the database. This would be like the metadata, the documents, or something like that. You plus the vector, obviously, that was stored in there. So this get method allows you to specify the ID, and it will get you the result back immediately. And you can inspect, I don't know, the embedding, the document, and whatnot. Make sense? Nice.
Absolutely.
So with the query, there is another overload that we didn't use. You can see there are 2 overloads. And it's pretty interesting because similar to the add method that allows you to put there multiple IDs, multiple vectors, basically multiple of each, it's the same with the query. So as you can see from this signature, I'm not only allowed to put just one vector as the embedding, which I did on line 21 with the dog, but also I can put multiple of these vectors. So basically, I'm looking for multiple matches and get the result back and loop through it. So it's like one round trip and do multiple, I don't want to say multiple queries because that would mean that it's like multiple operations. It's still one operation, but allows me to pass like multiple embeddings and get multiple results back and give and get the distances between each of these items there, so I don't have to loop through it or something like that. Good. I have a question for you, Shay.
Okay, I'm stressed.
That's fine. On the client, there is a special method that I've actually like never seen before. There are actually two that might be interesting. The first one is a little bit easier, and that's this one. It's called reset. It allows you to basically reset your Chroma instance to the initial state. Like you don't have to delete the data, delete the collections and everything. You can just reset it and like start again. So for like local development, that's pretty interesting, I would say. What about you?
Yeah, I've never seen a thing like this before. Like in other databases, it's definitely very friendly for like getting started, right? Like in a way. Yeah. I've never seen something like this in a database. Interesting.
Yeah, I'm thinking about it as a like truncate all tables, basically, right? Like drop everything and then and continue doing what you are doing. But there is another one that is kind of weird for me. It's heartbeat. So what the heartbeat does is basically sends a request to the server, receives back, I think it's number of milliseconds since January 1st, 1970 or something like that. It's just opaque value. It does not have any meaning or number of nanoseconds, milliseconds. We can actually check.
This one I am familiar with, much more.
Oh, it's not a result. We already used the result. Yeah, number of nanoseconds, basically. Yeah, that's fine. But
also,
yeah, go ahead.
No, go ahead.
When I was implementing this method, I obviously understand the heartbeat that allows you to kind of like keep the stuff flowing and everything. The problem with this one is that it's HTTP. It's request response. It's not like there is a WebSocket or gRPC or something like that, which is interesting, isn't it?
Yeah,
maybe it's like a future-proofing thinking. I don't know.
So I can think of two things. So first of all, it's common nowadays in most SDKs to have some sort of, this is not only necessarily to keep the connection alive, it's to also just check if the database is online and if the network hasn't been cut. So, there's all these health check APIs nowadays in Aspire, for example, they're built in like in the dashboard. So for example, this could be just a thing to check whether everything is still there in terms of monitoring, right? And then the moment this fails, then something turns red and maybe it sends you an alert. And so it could be like basically just a monitoring infrastructure thing, which it's very good that it has it. And in fact, I think a lot of databases, every modern kind of database will have a thing like this. But even by the way, in HTTP, I know this from other places. HTTP now has, like for a while now, has had long-lived connections, right? It doesn't open and close a TCP connection every single time. And if you leave, a TCP connection or a HTTP connection like open for a very long time, maybe some annoying firewall in the middle or network device, decides, hey, this has been idle for too long, so I'm going to cut it. And because of this, it's kind of that's called a keep alive mechanism, right? That's basically maybe a way for you to keep your connection, like TCP connection, alive, so that it doesn't get broken in the meantime. Like in NPG SQL, like the Postgres driver, there's a similar mechanism where it even is done for you automatically. Like you basically don't have to run it yourself. It just, you configure it and then it happens under the hood whenever it's needed. But this, I think, is the heartbeat is usually just a monitoring mechanism.
Yeah. Good. So what's the time? Oh, we are exactly on like 60 minutes.
I have two things still that we need to handle in terms of discussion.
Go for it.
Unless you have more stuff, of course.
Nope. Go for it.
No? Yeah, I mean, this is a super cool already. It's like a super cool comprehensive thing. I like in this sort of API, first of all, how easy and nice the APIs are, right? Like you're just, it's easy, right? Even compared to, like, if you compare it to a SQL database, by the way, then there's no SQL here, right? There's no, you're not like dealing with connections and commands and and all that stuff, and then you need to know SQL, how to select things. It's really just it's a more high level API, because these databases are more constrained in general, right? Like
that's true.
they're right. So you also get a higher level API, and it's just a more modern concept of what a database is in a sense as well, maybe. Anyway, so it's a really nice API. And one question that we got here was, what were like the challenges or difficulties in like you participated a lot in writing this SDK, and you know, the audience is interested in knowing how it was. What were the challenges, the biggest challenges in making a client for ChromaDB?
Yeah,
maybe you can talk about that.
I think you can even see it from the version that Chroma is not like a stable product with version like 7, where you can rely on documentation and testing and examples and everything. So probably the biggest problem was getting the information that needs to be sent to the server, what the server is going to respond with. So the implementation was, as you would expect, taking the Python and TypeScript implementation that Chroma provides like out of the box, and looking into these objects that are being passed back and forth, and understanding what's being sent left and right, and doing the same stuff in C#. So that was the first one. The next one, which would be similar to any library. Obviously, you can do one-to-one mapping between what's in Python and do it in C#. That would be pretty easy. But the API and everything would be pretty ugly. So finding the balance between making it feel like it's a .NET SDK, it's a C# library, versus, in case you already know Chroma and you want to start with the .NET for some reason, then like, okay, I'm familiar with the API, I know what to expect, it just feels like .NET. So the balance between, is it exactly the same as Python, so everybody can like understand it and everything, it's exactly the same as the default one, versus having a nice .NET implementation. And in fact, I think this library, even though we can claim it's a nice API and high-level objects and everything, it's still a low-level SDK. I'm not expecting everybody using this type of SDK. In fact, with the Microsoft Extensions AI and Microsoft Extensions Vector Data, I would expect that sooner or later, me or community that would be great, creates a connector for Chroma using this SDK to these higher level libraries, so that when you actually want to store something or do some search, you are not going to do it as we did here completely manually, but you will just use Microsoft Extensions AI or Vector Data to store the data, get it back, get the embeddings and everything around in like a little bit higher level library or API.
Super good points, and that leads me exactly to the last point that I wanted to say, which is to talk about Microsoft Extensions Vector Data, like 2 seconds, because people are probably unaware. So, like Yiji said, this is a low-level SDK. It's fine. Like I look at this, I actually think it's really fine. Like I would be okay with using it, but there is still there's 2 problems, right? First of all, maybe we have an ecosystem here in .NET, and maybe somebody wants to write a component that can work against any vector database. For example, maybe somebody will want to do something to do rapid retrieval augmented generation, RAG, the pattern I described in the very beginning. Maybe there's some tool we can do around this, right? And that tool would have to be able to use any vector database. So you should be able to plug in any vector database into it. So what we're missing here, like this SDK is great, but it's a specific SDK. And if you now go and see how you use a different database, it's going to be a completely different API, right? So how do you bridge this gap? What's missing is basically an abstraction, right, in .NET. So just like when you use a relational database, like a SQL database like Postgres and SQL Server, you have an abstraction. It's called system data or ADO.NET. With types like DB connection and DB command and all of that stuff, you have an abstraction there. Something like this is also needed for the vector database side of things. And in fact, that is currently in progress. There is something called Microsoft Extensions Vector Data. We're working very hard to get it. It's not yet released. It's in preview. You can already download the preview for this, but we're working. I'm really, literally right now spending most of my time working on that abstraction. And that's something that you can put on top of the low-level SDK, right? In this case, the Chroma SDK, to basically use it via an abstraction. It's really two things. A, it's an abstraction that allows you to abstract away the specific implementation, so you can plug in any sort of database. That's one thing. But it's also a bit more high level, exactly like Jiri said. So if you look at it, what we did with MEVD, with Microsoft Extensions Vector Data, we went a little bit more in the direction of something like EF. So it allows you to give a .NET type with properties on it and map that directly to the database. So maybe you saw in the code that Jiri just showed, you're dealing with property names as strings. Everything is like completely dynamic, right? Thank you for showing this, right? Like the name property here is not strongly typed. It's just a string. So it's basically all dynamic, right? As it's expected to be at this low level, right? That's the way the world works. But if you use the higher level abstraction that we call Microsoft Extensions Vector Data, then you can basically have a class in .NET and then map that to the database, just like you do with EF Core. It's of course not EF Core, and it's not as elaborate and big like EF Core, but it does do this sort of mapping of .NET types. Another thing that it does, you triggered me on this usually a little bit before, is we thought for a long time, how are we going to do this filtering mechanism, this where that you just right? Like this thing with the not in, maybe you can even select it so the users see what we're talking about. So this is like a big problem. Like now we're supposed to do an abstraction over vector databases. What's going to be the abstraction for the query language there? That's like quite a problem, right? This one is specific to Chroma, but again, something else is going to have a completely different thing, and it's a tough problem. And what we ended up doing, and that's literally going out like in a few days, the new version, the new preview version, is to use LINQ. So basically, you can express your queries a bit like you do with EF Core by using LINQ, by using .NET code. You pass a lambda in, and it's an expression tree and everything. You basically use .NET code to express the condition, like the not in or the equals or whatever, right? It's not EF, and it's not even close in terms of like what kind of LINQ constructs it actually supports. It's very, very limited and constrained, but it allows you to basically express the filters that most vector databases support. Like most of these databases, like I said before, they don't have amazing querying capabilities either. So it's feasible to just do it via LINQ and support the things that they support. So basically to summarize what I'm trying to say, soon the idea is you will have a higher level way of interacting with vector databases that also abstracts over them, so which makes it much easier to switch across databases or to plug databases into a common component that doesn't want to care about which database exactly, right? Soon you'll have this thing, which will in principle make your job much easier when trying to interact with these databases. But still, this sort of lower level SDK is super important. I'm very happy to see that we have it. First, because maybe you really do want to just go low level because you want to use very specific features of Chroma. At that point, you have to use the low level SDK. The abstraction will not have or will not cover all of Chroma's features, but you can just use this SDK, and that's fine. And the second reason is that basically you still need something to build the abstraction on top of, right? So the Microsoft Extensions Vector Data, it has these connectors, and they're built on top of this sort of low-level SDK. So this is a foundational component. It's the first thing that's needed in order to use Chroma in the .NET ecosystem, and now we're going to build on top of it and make the story even nicer. But that's going to take a couple more months, I think, more or less. I think that's basically what I had.
Yeah, and the idea with like Microsoft Extensions AI, Microsoft Extensions Vector Data is also that you have like common ground for building on top of that.
Exactly.
Be it a template for Visual Studio, be it like a helper methods for Razor pages and so on.
Exactly.
Because you can have like the response from the language model can be streamed to you. So you are getting what you are probably used to see is like one word or one character after each other showing up on screen, so it feels like it's actually being generated. Or in some scenarios, this is not what you want, so you want the full response back. And these common grounds allow you to have like, hey, do you want to use this? We have a plugin, like a Lego block that you can put into your AI-enabled application, be it ASP.NET Core, Console app, whatever, MAUI. And it's just, as I said, Lego blocks that you will plug into your Maui app, and you can put these pieces together as a Lego, and it should just work. While if you would be using this low-level SDKs and APIs to talk to Azure OpenAI and everything, you would be putting everything together, including like error handling and parsing the responses and everything, which is not fun.
Absolutely.
Awesome. So we are again 10 minutes over the time, but it's fine. We are always over the time. And I think people kind of expect us to go a little bit over because we are so excited and so interested in what we are doing. So it's difficult.
This time we were 10 minutes over also because we had screen sharing problems though.
Okay, yeah. So we are almost on time.
Almost on time, exactly.
Almost on time. It's basically StreamYard's fault, not us. We need to figure out what to do for next. Maybe it was my machine. We don't know. Maybe it will solve it itself until next time. So the next stream is going to be pretty close because we shifted this one basically 8 days. So keep an eye on that one. It's already scheduled. It's going to be a great one. I'm really looking forward to it. It's like in 3 weeks. So go check out the schedule. If you have any questions, any ideas or something like that, feel free to send them our way through the EF Core repo. And we will see you in like 3 weeks, right, Shay?
I don't remember when the next one is.
I think it's in 3 weeks, if my computation is correct. So it's already scheduled. It's already on YouTube, so you can have your notification, everything enabled. And okay, see you next time.